Hey everyone, I'm Wojtek. I'm based in Kraków, Poland. I'm the author of Rec, HTTP client, and I work at Dashbit. At Dashbit, we do basically two things. We help companies adopt and run Elixir in production, and we help growing the open source Elixir ecosystem. And it's a nice arrangement because we work on some libraries, frameworks, people use it, the community uses it, our clients use it. And then as we work with clients, we see how they use it in production, and we see that maybe they run into some issues. And so we get that feedback, and then we can get it back to the libraries, improve libraries. So a nice example of this is Broadway, where we exactly saw people using GenStage and kind of running into some problems. There was missing an abstraction, so we created Broadway thanks to that feedback. This feedback cycle, this virtuous cycle, was definitely not the reason that I created Rec. We didn't really have clients knocking on our doors demanding a new client, and that's because we already have a bunch of options. We have HTTP-C, which ships with OTP. We have Hackney and HTTP Poison. We have Eyebrows and HTTP Potion. We have Gun, but we also have Mint, and Mint is not quite like the others. It basically has zero dependencies. It is very low level. It is pretty verbose to use, but you have full control. We also have Finch, which is using Mint, but it has connection pooling on top and some ergonomics. So Finch, yeah, definitely easier to use. We also have Tesla, and Tesla is also not quite like the others. So some clients have kind of like higher level features like following redirects or decompressing responses. Tesla has those features, and it has them using building blocks. In Tesla, they are called middleware. They are modules, and in Tesla, so Tesla ships with a bunch of these middleware, and when you use Tesla, you pick which middleware you want to use in that scenario. And then, yeah, Tesla uses HTTP-C by default, but it has built-in support for pretty much all of these. So some notable mentions. We also have Katipo, which is Erlang library that uses libcurl, so it has access to a bunch of features. And then we have RQuest, which is also an Erlang library that actually uses Rustler. So it's pretty interesting. It uses Rustler to integrate with the Rust request library. And finally, we have Rec, which I'm going to talk about. Rec is similar to Tesla in that it is extensible. The HTTP features are implemented as basic building blocks. In Rec, they are steps, they are functions. Contrary to Tesla, they are all enabled by default. So it is opinionated like that, but the steps are written in such a way that it should make sense. They are kind of smart about it. Rec uses Finch, but you can plug in a different adapter, but you would have to write it yourself. So we have a bunch of options. It's like 12 of these. There is definitely, in a short talk, there's no way I could give justice to these different options, kind of talk about pros and cons, trade-offs. I could give them injustice by picking, totally random, not contrived at all example where maybe Rec shines, but these other options not so much, but that would be unfair, so not gonna do that. And instead, let's see how we can use Rec. So let's say in IX session, we can mix install Rec, and now let's pick a totally random, not contrived at all job to do, which is, to be fair, pretty common thing to do, which is just to grab some data from a JSON API. So here is the URL to the GitHub API for getting information about repositories. And so with Rec, we can call rec.get with the URL, and we would get the Rec response struct. So we got status H200, we got headers, there are map, and we have content type application JSON. And because content type is application JSON, Rec automatically JSON decoded the response body to Elixir terms, in this case to map. And so moving the code around just a little bit, instead of making the call right away, we can build up the request. So it's data, we can pass the data through some things, change it, and only then at the end make the request. So we have the same kind of the same idea. So we can inspect the response body. Again, headers are a map. This is contrary to pretty much all the other clients, including the last version of Rec. Turns out map is pretty ergonomic to use. We can use the access behavior, the square brackets syntax. We can pattern match on maps. HTTP headers, though, can be sent multiple times in a response, and the semantics are that like if it shows up multiple times, the semantics are it should be kind of merged. So hence, in Rec, the headers are a map of string header names to a list of values to support that use case. And then, yeah, we can inspect the response body as well. So the tagline is, it's batteries included. So the analogy is you buy something, you take it out of the box, it has batteries included, it's ready to go, it's easy to use. So, you know, nice out-of-the-box experience. And that was my goal with Rec, to have these high-level functions where you do common things very easily, but you can also extend, which we'll see soon. So some of the features that we have request body compression and automatic response body decompression. The automatic bit is important. We are talking about soon. And these features are implemented as steps, so functions. Each function is well documented. You can look at the source code of each individual piece at a time. They have examples, doc tests. Rec supports gzip by default, and if you install additional dependencies, we support broadly and zstd decompression as well. We have request body encoding and automatic response body decoding. So, for example, we automatically JSON decode the body. We have support for authentication. We can set up base URL, which is really convenient to build API clients. We can encode parameters as query strings, so again, kind of building up the URL. We can automatically follow redirects, retry on errors. We have basic, like very, very basic support for caching. And then instead of hitting the network, we can hit a plug. And this is, if you have heard about a library called bypass, which is really convenient in tests. So with bypass, you start like ad hoc HTTP server and you instrument it using plug API. I think it's a great way to test, and I kind of stole the idea and baked it in. So instead of hitting the network, you can just hit a plug. And we have pluggable adapters. By default, Rec uses Finch, but yeah, you can bring your own. Some new features, as in like 2 weeks ago, we can stream request body and stream response body. We're gonna see that soon. So continuing with the analogy, we have batteries included, but we can also replace batteries. And Rec has basically 3 parts. We have the module that you would use most often. And then there is the Rec request module, so that's the lower level API, but that's part of the public interface. It's going to be stable. It's going to be backwards compatible at some point. And we have Rec steps, so that's the module, the collection of built-in steps functions. And so let's talk about the struct in some more details. So here's an example where we build up the struct. So we set the URL, and maybe we turn off the automatic redirection. So we would get some basic HTTP stuff. We have method get, the URL, the headers, the request body, and then we keep track of options for a very, very particular reason. And in fact, we keep track of available options as well. We are gonna see soon why. And we store the adapter, so by default we use Finch. And then we keep track of all of the steps that are available for this particular request. They are a list, the order matters. So we have request steps. These are all the built-in ones. Response steps and error steps. And again, they are enabled by default, but you can change things. And so when we call rec.get, it is as if we started with rec request new, which is basically blank slate, no steps, and just kind of start building up the struct, so setting up some data. And then it is as if we start calling functions, so just taking the data and passing it through functions, through steps. So we set the default user agent, we encode the body, we compress the body, and again, the order matters. We first encode the body and then compress it, not the other way around. And this is, again, kind of contrary to Tesla. In Tesla, you have to put the middleware stack yourself, which is pretty obvious, like what the order should be, but sometimes in some specific cases, it is not quite obvious if something should be, earlier or later. So in Rec, we set everything up in an order by default. And then after we pass through all the steps, we call finch. So we would get one of two outcomes. We either got HTTP response back, or we got an error. So the server was down, the server was timing out. If we got a response, we take the request response tuple and pass it through response steps. So for example, we automatically retry. If the response status was, let's say, 408 or 500, we automatically retry. We automatically make another request like the one before. If the status was 301 or some others, we automatically redirect using this function. And then let's say if we have header content encoding, meaning the server compressed the response, we automatically decompress. And again, the step kind of looks if the header is there. If it's not there, it just doesn't do anything. And yeah, we decode the body, so JSON decode the body, for example. Similar idea with error steps. We have, for example, retry, and retry is kind of interesting step. It can be used as both response and error step. We retry on error responses like 500s, or we retry on transport errors like timeout or connection refused. And so this is roughly how Rec works, just getting some data, passing it through functions. It is not quite exactly how it works because it is basically between each step, there is like a hidden control flow to where Rec takes over, and based on the return of the function, it does things. And so let's talk about steps in some more details, and let's write a custom step. So here we just hit the website, and let's add a request step that takes a request and returns a request. It's just IO inspects the URL. And so it is really easy to write. The step is just a function, and then we just append it to our request struct like this. The word append matters. Append added to the end of the list. There's also prepended added to the beginning of the list. And the contract for steps. So yeah, again, we have three types: request steps, take a request and return it; response steps, take the tuple and return. Of course, as always, potentially updated. And then error steps, take the tuple and return it. This shape, this contract is enough to implement a lot of features. It is not quite enough for all of them. And so request steps can also return request response tuple. And an example for that is a caching step. Let's say you take a request and see if this request was already cached, if there is a cached response for it. If there is such a response, we return request response tuple, and then Rec is going to stop passing the data through request steps, so not gonna hit the network. It's gonna take the tuple and pass it through response steps because we may want to still decompress, decode, and so on. If there was no response, we return the request. We continue with the steps. We hit the network. Same idea with exceptions. We can return exceptions. An example is secret breaker. We are not supposed to hit the network if the breaker is open, so we are not gonna. We return the tuple. We are gonna take the tuple and pass it through error steps, and that's because we may want to have steps to log errors, retry, and so on. And same idea with response steps. They can return exceptions, so we switch the flow. Error steps can return responses. We switch the flow as well. So that's that kind of hidden flow. This contract for request steps in particular is exactly how we support adapters. An adapter is just a request step that returns either response or exception. So there is nothing magical about them. The only kind of important thing is that adapters are special in that they have to be the last request step, but that's it. So we are going to do a demo. And so, yeah, I have so we have the rec hello world, we hit the API, we get the JSON body. Let's now take this out, and instead of making the request right away, we will build up the request struct, and we are going to use the base URL feature. So we build up the request. So this is useful in live books, but also useful in production code in API client wrappers. So let's see if this still works. Still got the same result. Let's check out Finch. Yeah, HTTP client focus on performance. It really is, and basically Rec is extremely fast because Finch is. So get that for free. Let's talk about some more Rec features by inspecting what Rec actually does. And for this, we are going to use the plug feature, which is really useful, as I mentioned before, in tests. So we can kind of do fake responses, but also inspect what it was that we sent. So we got the response. So status 200, body hello. But now what we can do is inspect, IO inspect, let's say the con headers. So it's Rec headers, and we see it here. We set the user agent by default, but we also set accept encoding. And it means that when the client sends it, it's like, hey server, I support these compression algorithms. If you compress the body with these, I'll be able to decompress. Sometimes we may not want to do that, so we can set compressed to false, and then we are not gonna ask the server to compress things. There is quite a lot of options. We can set method, URL, authentication, URL options. Sometimes you may forget how an option was called. Never happened to me. And for that, when we mistype an option, we have an error, unknown option compress. Did you mean compressed? We keep track of available options exactly so as to have this nice experience. Okay, so let's keep inspecting what Rec does. Like this kind of inspecting what actually happens is so often that there is an excellent service called HTTP bin, where we can do, let's say, hit like a URL, and then it's gonna return a response with that status. So if we go to HTTP bin status 202, we're gonna have 202, and then there is a bunch of endpoints to test, various aspects. Now, right now, this service is very fast. It was not fast at all like 2 months ago or a month ago. It was flaky, it was timing out, it was down, which then I was in my integration tests. I was hitting the service, and my tests were down. I was definitely part of the problem. I was definitely not the only one that was doing that and maybe making things worse. And I was like, so I probably should work on this talk, but I'm a programmer. I can fix it. I created a little HTTP bin clone called recbin. Oh no. Okay. Yeah. Fly. What did you do? Okay, it's fast. I need to change my config. Yeah. So basically, same idea. We can hit some endpoints, change different aspects. We can do like a JSON endpoint, for example. And then there is a very useful inspect endpoint. So inspect endpoint inspects what was the request body that we sent. And for this, we are going to inspect what happens when we make post request. So let's make a post request with the body, let's say, hello. And yeah, we got the body hello. That is the body that we sent. Instead of sending the string body, we can send JSON. So the body was JSON encoded. We set the proper content type. We can, instead of JSON, we can send form. So it's form URL encoded. The body got URL encoded as well. Instead of sending strings, so this is like making eager request bodies. We send like the whole request body at once. We can also stream request body, and usually in Elixir we stream with enumerables, the enumerable protocol, and a very simple one is a list. A list implements the enumerable protocol. So if we send this enumerable, it ends up as the concatenation of these two strings, but we can do any enumerable. So there is a nice little function called stream duplicate. We can duplicate things how many times, and it's a lazy stream. So here, yeah, we got the full 3 times here. So speaking about streaming, so this is request streaming. We also have response streaming, and for that, first we are going to hit the there is an ND JSON endpoint. It needs to be a GET request, and ND meaning new line delimited JSON. So we have a piece of JSON, and then it's new line delimited. Right now we take the entire response body. Take the entire response body into memory, but we can stream it as well. And so for that, we have the into option, and we can give it a function, and we would get each body chunk, and then an accumulator. The accumulator is to keep some stuff around. And then we would return either cont to continue streaming, or we can return halt to stop streaming, to cancel the request. But here we are going to continue, and we would inspect the data that we got, and let's put a label on it, chunk. So each chunk got streamed. It got the function was called with each chunk, and so we can send a message to another process, or maybe stream to a file. And speaking about that, the choice of calling this option into was very deliberate. In Elixir, into has a very particular meaning, and that is to we can kind of take stuff into collectibles. So we have enumerable for streaming things, and we have collectible for collecting things. Data structures can implement the collectible protocol. And so again, very nice example is a list. List can be collected into, and so we collect in each chunk into a list. We support any data structure that implements collectibles, so it can be, let's say, map set new, for example. Each chunk got put into the set. In the standard library, there is a very nice collectible, and that is returned by IOStream, and it streams. It basically collects things into the standard out. So standard out, each chunk got printed to standard out, and similarly, we can stream to a file. So we don't take the entire body. Each chunk, we only hold part of the body in memory and then stream it to the file. So on the opening keynote, there was a piece about distributed Elixir, if you saw, and the vibe that I got was we don't maybe use distributed Elixir enough. That got me an idea. So I'm using the Tailscale program, which is really cool, and I happen to have my iMac back in Krakow, Poland, running here, and it still works. So I have a little ElixirConf folder. Currently, it's empty. I have the node running, and what we can do is the following. So where is my notebook? Yeah, what we can do is the following. We connect to my iMac. As you can see, the current time is 3 p.m. back in Krakow. And here in this call, we can call anything. And as a matter of fact, we can stream, so open a stream to a file on another node. So we can do ND, so it's going to be ElixirConf, ND JSON. And let's take this. And let's collect into, and I lost my, so let's try if it works. It works. Let's double check back in Krakow. We got the file. Hold on. Yeah, it's gonna work. Give me a second, sorry. Yeah, we got the file. So by supporting Elixir data structures, enumerables, and collectibles, we have access to the vast ecosystem, and we can just easily stream to another nodes across the ocean. If you ask me, this is pretty cool that we can do that. One of the goals was to be extensible. As we work on, as we add steps, custom steps, and we want to share them with people, to make it even easier to share, what we can do is wrap them up into plugins. And there isn't a plugin contract; it's just a convention. But for that, let's hit the GitHub API. Again, there is a user endpoint, and it requires authentication. It gives information about the currently logged in user. And for that, I created a little rec plugin called rec GitHub OAuth. So let me show you this. Oh, spoilers. So now, if we hit this endpoint, we need to attach. So we take rec GitHub and attach it. And now, if we call this, we are gonna get this message printed out. So paste this user code to this endpoint. So let's do that. Let's authorize, and then going back, we got the response. So let's double check. Yep, that's me. Another quick example of a plugin is, let's hit the Elixir website. It's a string of HTML. So I created a little plugin called rec easy HTML. And let's attach it. And now we automatically decoded HTML into a data structure. It's easy HTML data structure. It implements the inspect protocol to pretty print HTML tags. So they are nicely indented, but under the hood, it is probably what you would expect, just tuples of elements and attribute names and all. So yeah, I was hitting the network all the time with my rec, with all of these. Instead of hitting rec bin, let's actually go back there for a second, maybe to this inspect endpoint, and yeah, thank you. Still works. Instead of hitting the network, because recbin is written in Elixir, we can just start it, which I did. All this time we had a recbin running on port 4040, so that could be pretty useful to in tests. You can just spawn this server and hit it instead of going across the network. And in fact, as you might guessed, recbin is written using plug, so we can hit the plug instead, and it still works. Now that domain doesn't matter because we're not actually hitting the network. And as you can see, we print some logging because in the same process, in the same VM, we run the server and the client. And just one little feature, just one little mention. All this time we attached both of these plugins, and that's the idea. The steps are supposed to be running all the time, but they need to be smart when they take action. So the rec GitHub plugin is sending the authentication token, but it's not supposed to send it every time. So we can inspect. Let's actually do a little plug. Instead of a plug, let's do an adapter. Let's do a quick fake adapter. So just returning a request and response, and inspect the request. So we got the data structure, the headers. For this URL, we did not send authentication, but if you go to api.github.com, and again, we are not actually going there. We are not hitting the network. We are hitting the plug, but the plug gets the host. Oh yeah. That is HTTPS. Yeah. Yeah, we got the authorization header, but in order not to leak the details, the rec request tract actually implements the inspect protocol and hides credentials as well. So yeah, this is pretty much it. To close off, missing batteries, I want to add proper caching support. I want to add cookies and multi-part. But this is not going to stop me. We are going to have rec 1.0 pretty soon. I think the API is stable. I can add missing features without breaking anything. I'm planning to release it in late October in an unspecified year. And thank you so much. That's it.